Hey there, my name's Gary Sims and this is Gary Explains. So Google has announced the new Pixel 6 and Pixel 6 Pro and at the same time revealed the details about its new system on a chip SoC, the Google Tensor. Well, there's been lots and lots of rumours and speculations about this chip over the last year and now we have all the details. So if you want to find out more, please let me explain. Okay, so let's start with what the Google Tensor is not. Now this is more from rumours further back, maybe not so much recently, but when people started to hear about Whitechapel, that was the code name for the Google Tensor, people started to think that Google was going to design its own CPU core like Apple does for the iPhone. It thought it might design its own GPU core like Qualcomm does for the Adreno, and then on top of that add in its own kind of machine learning stuff. So every part of the Google Tensor Whitechapel SoC would be Google design. Well, that's not what happened. What we actually have is a system on a chip very much like you'll find from MediaTek, from Samsung, from Qualcomm, with ARM CPU cores and ARM GPU cores inside of the phone, and then around that they've added in some other stuff to do with machine learning. In fact, Samsung is actually Google's partner for this, and it would probably be that Samsung and Google have worked fairly close together because in many ways this is probably an Exynos chip that's kind of been given over to Google. Google have added in their Tensor stuff and basically then Samsung manufactured it for Google. So kind of a flow of information in both directions there. But this looks very much like a standard SoC that you do find from companies like Samsung and from MediaTek. So in a minute we're going to see how this compares to the Snapdragon 888, how it compares to the Exynos 2100, but let's have a look at the specifications of the Google Tensor. So the big reveal here is that it has two ARM Cortex-X1 CPU cores, then two Cortex-A76 CPU cores, and then four Cortex-A55 CPU cores, and then an ARM Mali G78 MP20 GPU. Now that's quite a unique configuration. So the Snapdragon 888 and the Exynos 2100 have one Cortex-X1 core, and all the presentations I've ever seen from ARM itself talk about one X core and then some other cores like the A78 around it, and that's what you get in the Snapdragon 888, that's what you get in the Exynos 2100. For laptops, then ARM did talk about maybe you want to do 4 cores or other variations of the X1, but the X1 is fairly power hungry. So although it offers a lot of good performance, it does kind of eat away at that battery life. And so the fact that Google have gone for two X1 cores here is quite a unique revolution. And so what they're trying to say is it's not only about single threaded scores that you might get, you know, from Geekbench or something like that, but also it's about the fact user experience will really benefit from having two high performance cores that are actually better than the Cortex-A78, you know, the top edge that you can get from ARM at this moment. And that's what they've done. And I'm sure there will be some usability and some kind of, you know, user experience benefits of doing that. But of course, once you've got these two huge cores in there, you've now got a power consumption problem. You now got to work out what you can do with your battery life. And so rather than putting in the Cortex-A78, which is what Snapdragon, Qualcomm and Exynos Samsung have done, what they've actually done is gone for the Cortex-A76, not even the Cortex-A77, the Cortex-A76, and at quite a low clock speed as well. And so why they've done that is because, as I say, when you've got all the cores kind of up and running, you're doing something fairly heavy lifting there, then you don't want to have some Cortex-A78 cores in there because then the battery life really will just crash completely. So they've gone for the A76 several generations before, a good power efficient high performance core, not as fast as the A77, not as fast as the A78, not as fast as the X1, but they've kind of struck this balance between X1 cores for ultra performance and then something in the middle cores that are older, more power efficient, and then below that the Cortex-A55 cores, which kind of everybody just uses for the power efficiency cores. Now what that's going to mean in terms of performance is that when you come to single threaded performance, or even if there was a kind of a dual core performance test, it's going to come out really well, and that's going to be good for user experience. But when it comes to overall multi-threading, because you've now replaced Cortex-A78 cores with Cortex-A76 cores, then you are going to get an overall multi-threaded drop in performance, and we'll talk more about that in a moment. And then just quickly talking about the GPU, this is the Mali G78, so that's the best and the latest from ARM at the moment, and they've gone for the 20-core version, so that's much, much more than you find, for example, in the Exynos 2100, so they really are kind of pushing the boat out there for the GPU, and that could be a fairly fast GPU. It'll be interesting to see what the benchmark numbers actually turn out to be. Okay, so let's compare the Tensor to the Snapdragon 888 and to the Exynos 2100. Well, of course, the first thing to note is, as I said, is that the Snapdragon 888 and the Exynos 2100 both have a single Cortex-X1 CPU core, roughly talking about the same speed here, 2.8 gigahertz for the Google, 2.84 for the Snapdragon, 2.9 for the Exynos 2100. In fact, it hits 3 gigahertz for the Snapdragon 888 Plus. And then rather than there being 3 Cortex-A78 cores at, well, you've got 2.4 gigahertz in the Snapdragon 888, 2.8 gigahertz in the Exynos 2100. Now we have 2 Cortex-A76 cores down at 2.2 gigahertz, so quite a lot lower in terms of clock speed and in terms, of course, of the architecture of that particular design. And then when you come down to the Cortex-A55 cores, 1.8 gigahertz is a kind of the standard speed, though noting the Exynos 2100 does have it running at 2.2 gigahertz. And then when we get to the GPU, as I said, we've got the Mali G78 MP20, the 20-core version. You've got the MP14 in the Exynos 2100, so a much, much beefier version in the Google Tensor. And of course, Qualcomm have their own GPU in the Adreno 660. Now, all of these, of course, are built on 5 nanometers. So what that means in terms of overall performance is I think you'll find that the Snapdragon is going to still be the fastest for single-core performance and for multi-threaded performance, and that's going to be closely followed behind by the Google Tensor and the Exynos 2100, depending particularly on the workload. If it's GPU related, then I think you're going to find that 20-core version in the Tensor is going to be better than the 14-core version in the Exynos 2100, but the Exynos 2100 does have faster Cortex-A55 cores in there, and of course it does have those Cortex-A78 cores, so in kind of pure multi-threaded CPU-bound tests, then I think that you're going to find that the Exynos 2100 is the better. So that puts it kind of in third place in terms of overall performance. MediaTek, of course, up there as well. We've got the Dimensity line of chips as well. It's going to be interesting to see where the actual lines are drawn in terms of performance. But in terms of CPU and GPU, this is an interesting chip, an interesting configuration, but it isn't going to go away with any of the gold medals. Now, of course, the big thing that Google wanted to emphasize during the launch of the Pixel 6 and the Pixel 6 Pro was, of course, the Tensor stuff. That is basically machine learning that you can do on chip without having to rely on servers. Now, I personally find that quite ironic. When Google Maps was first launched, I think it was in around 2005, 3G was the thing then. 4G was at least another kind of 5 years away from its official announcement, and several more years than that before it's kind of like rolled out across different countries. I remember seeing Google Maps and seeing a demo of it. I'm thinking, well, there's no way I can run that because I just don't have the 3G connectivity. I don't have a good subscription that gives me that kind of data that's going to be needed for that. Google really are pushing for the use everything online. And of course, that is what Google do. Google is the internet company. It's the search company. You do everything online. Even the Chromebook is designed so you can access, Google, Gmail, Google Docs, and it's all in the cloud, all online. Google Photos, all online. Now, it does have some stuff you can do locally when you're not connected, but ultimately it syncs up again with the cloud because everything is in the cloud with Google. Google Maps in the cloud, Google Photos in the cloud, Gmail's in the cloud. Everything is out there and nothing is locally on your device. And now all of a sudden Google is saying, oh yeah, but when it comes to machine learning, let's do it on the device. You don't need our servers anymore. Now, there is a good argument for that. It's a really good argument, but it's actually the same argument for all the other stuff that Google does. So actually having your emails locally, actually having your photos locally, actually having all your documents locally, it's the same argument. What is that argument? Well, privacy. You're not loading all up to the cloud where it's available from, disgruntled employees, government agencies, hackers. It's all out there on someone else's computer. It's not on your computer. Of course, you've got you've got speed. You don't have to connect over the internet to get something because it's here locally. And of course, there is even a benefit for the environment because you're not having to power huge servers that are running in these huge data centers that consume lots and lots of electricity, just kind of keeping all my photos stored somewhere on a server that Google have got. So Google is saying, hey, wouldn't it be better to do ML on the local device? And that's true, but it's a really funny argument for Google to come up with that one. But there you go, that's what they're saying. Now, of course, it is a good direction to go in, and I understand it, but there's nothing particularly, new about it. I mean, they spent a lot of time talking about how you can erase objects from photos. Well, there's apps that do that for you now. Where's the great thing in that? They talked about how you can do translation of conversations, and yeah, it's called Google Translate. You've been able to do that for a long time, but yes, you do. It goes up onto the cloud and comes back again. This is doing it locally. I understand the difference, but it's not as if like, oh wow, I've never seen translation before. Oh, I've never seen objects being removed from a photo before. And the whole presentation was going, dictating, your voice to the phone so you don't have to type on the keyboard. Well, I do that literally all the time because, I don't always have my hands to want to type on the little keyboard. I talk to Gboard, Google's keyboard, and it dictates messages. Now, yes, it's getting better and they're improving it, and, that it's going to be running locally. All great stuff, but none of this stuff is new. I've seen it all before for years, and it all came from Google in the first place. So, yes, I understand it. Yes, locally is better than in the cloud, but so it was before. But Google are the one that kind of pushed us all into the cloud in the first place. So what does that mean, the Google Tensor is? Well, it's a new kind of configuration of chip, 2x1 cores, bigger GPU, the NPU, the machine learning stuff. Yes, very good. It's going to be an interesting... Is it going to be a niche? Probably just going to be a niche. Is it going to revolutionize things? Probably not. All it will actually do is mean that other manufacturers will keep upping their machine learning game. They will certainly try to do more and more in terms of NPUs, neural engines, all that kind of stuff. And 2-3 years they will do the same thing. And Google will support all of them because it's running Android. It will need to support all of them in the end. So, yes, well done. Have my socks blown off? No, not really. But I will say one thing. I haven't talked about the Google, the Pixel 6 in general, because obviously it's much more. It's a camera, it's battery life, it's a display, all that stuff. I haven't talked about that. But one thing I'm impressed with is the pricing. The pricing for a device with such a kind of processor, with those capabilities and the cameras, and 5 years of security updates for those kind of numbers that Google were quoting during the launch, that is impressive. So I will say that about Google. Well done for the pricing. Okay, that's about it. Now, maybe you don't agree with me. Maybe you think I really am talking out of my elbow. Well, that's absolutely fine. I'd love to hear what you say in the comments below. If you did enjoy this video, please do give it a thumbs up. Also, you can follow me on Twitter and interact with me there at Gary Explains. And don't forget, I have a newsletter. Go over to garyexplains.com, type in your email address, no spam, just the newsletter. Okay, that's it. I'll see you in the next one.